Okay, so for this video, we're going to figure out an equation for this particular sine function that's given in the workbook, page 285, number 5i. Now, we want to write something in the form y equals a times sine of b times x minus c plus d. And the same thing, actually, for cosine. And so let's get started. We'll see if we have time for this option, but I at least want to show you how to do the how to figure out the equation for sine. So for the equation for sine, we should really just figure out all our parameter values, right? We should figure out a, we should figure out b, we should figure out c, and we should figure out d. As soon as we do that, then we can just plug them into these particular parameters in the equation, and then we're done, actually. So we just need to find these parameters. That's our goal. We know that for amplitude A, for the amplitude, actually, amplitude is just the absolute value of A. And so what is the amplitude? Well, the amplitude is really just the maximum. And then it's plus the minimum. And then you just divide by 2. And so here we can see that, sorry, little error there, maximum minus the minimum divided by 2. So 1 minus negative 1 over 2, which is 1. So we know the absolute value of A. We are told in the question that we want A to be positive. And so we will say that this is not only the absolute value of A, but because A has to be positive, given the constraints of the question, well, we should just leave it as positive then. So we found our A value, in other words. We found our A value. What about our B value? Well, we know our B value is really just 2 pi over the period. Technically, this is for the absolute value of b, but again, in the question, it says it wants a b parameter that's positive anyways. So we're just going to find a positive value anyways and keep that positive value. It doesn't really matter. So 2 pi over the period. So what is the period? Well, we can notice that we have one full period that's been graphed here. So here, between these two centerline points, we have one full period. And sometimes people get a little bit confused because they say, well, isn't this one full period? Because here we have two centerline points, but it's not, because it needs to go down through that centerline point and then up through that centerline point, and then when it's going back down through the centerline point, then we are truly repeating again. So this is one full period. And so what we need to do is we need to find the distance between these 2 points. So what's the distance between these 2 points? Well, the distance between any two numbers is really just the difference of those numbers. So pi over 6 minus negative 7 pi over 6. So this will be the distance between those 2 points, those two numbers. And this will just be 8 pi over 6, which simplified is 4 pi over 3. So that is the period. Let's write that down. This is going to be 2 pi over 4 pi over 3. And if we have one number, 2 pi, divided by a fraction, that's the same thing as saying 2 pi times the reciprocal of that fraction, 3 over 4 pi. And these factors of pi will cancel. And what else? Well, we will have 6 over 4. 6 over 4, or divide the top and bottom by 2, we'll have 3 over 2. So that's the b value. The b value should be 3 over 2. And what else? Let's see. We have, well, we want to find the c value, but we're going to leave that for later because that's going to be the hardest part. Let's look at the d value. The d value is really just the center line point, and we might be able to clearly see that, okay, if we have positive 1 as our maximum and negative 1 as our minimum, we might be able to see that the center line is just in the middle of those two. But in general, this is the formula that you can use to find the d value, max plus min over 2. And so that's just going to be 1 plus negative 1 over 2, which is 0. So that's our d value. So let's get to it. Let's get to the c value. We're looking for the c value here, which represents the phase shift. So what is the phase shift here? Maybe let's do this in a different color. Let's do this in maybe black ink. So we know that sine typically starts at 0, 0, right? So we know sine typically starts at 0, 0, and then it starts going up, and then down, and then up, and then down, and so on. But this clearly doesn't do that. It's been shifted, and we need to find the least non-negative number c for which it is shifted. So if we continue this red graph, we can see that this red graph would have been shifted to the right, if we're looking at a non-negative c value, by a certain number of units. And so how many units would it have been shifted to the right by? Well, one thing we can look at is where this point would be. So where would this point be? Well, we know that this point would be 1 full period away from this particular point. And we know that this point would also be, because it's 1 full period away from that particular point, and we know that the distance between this point and that point is a half period, then we can say that the distance between negative 7 pi over 6 and, oh, actually, an easier way to do this is just to notice that that this point is actually just, a half period. It's a half period away from a point that we already know, which is pi over 6. That's going to be even easier. So I was doing it the hard way. Let's do it the easy way. So this point is really just going to be a half period away from pi over 6. And we want to know what this point is, because then we'll have that phase shift value. So what is pi over 6? I'll do this in red. What is pi over 6 plus 1/2 period? Well, we know that 1 period is 4 pi over 3 units. So this is going to be pi over 6 plus a half of 4 pi over 3 units, which is just going to be pi over 6 plus 4 pi over 6, which is just going to be 5 pi over 6. So that is going to be the x value at this point. This is going to be a point that is at 5 pi over 6 and 0. That's going to be the particular point. So we know that this graph has been shifted to the right by 5 pi over 6 units. So we can say the c value is 5 pi over 6. So what does that leave us for our equation? Well, we're just going to have y equals a times sine of b times x minus c plus d. Our a value is 1. Our b value is 3/2. Our c value is 5 pi over 6. Our d value is 0. writing this all more simply, we don't need to write the 1. We can just write sine. And then we can just do 3/2 x minus the phase shift. And then we don't have to write the plus 0. This is good enough. So there you go. That's how you can write the equation for the sine, treating this particular graph as a sine function. You could do the same for a cosine function. It's just you would want to figure out how far it's been. The only thing that would change really is the phase shift for cosine. So for cosine, remember for sine, to figure out the phase shift, we wanted to know how far this graph would have been shifted to the right to find its regular starting point at 0, 0. And for the cosine graph, we would want to know how far this has been shifted to the right to get to its regular starting point at 0, 1. So you would just use a different reference for the phase shift there. So that's how you do it for cosine.